So after our introduction to elements and our specific look at atomic structure, now we need to start distinguishing between elements and compounds, the other kind of pure substance. So when I defined elements for you, I said that elements are pure substance which cannot be chemically broken down. So during a chemical reaction, you cannot take an element and make it any simpler and still have it maintain the chemical properties of that element. That's because their most basic subunit is an atom. When we look at compounds, compounds are still pure substances. They can't be physically or mechanically broken down, but they can be chemically changed into simpler substances, and that's because their basic subunit is a molecule, a collection of atoms. So when we look at molecules, there are three different kinds of molecules. The first of which is diatomics. Diatomics represent a group of elements that when they are present as elements alone, all on their own, they are bonded in pairs. I like to call them the fancy seven. Some people call them the NOF seven or the gang of seven. But the important part is that they're all about the number seven. They start at atomic number 7, that's nitrogen. You draw yourself a little 7, so nitrogen, oxygen, fluorine, then drop down chlorine, bromine, and iodine. And when you count them, there's only 6 elements. So in order to have 7, it's a little trick. In order to have 7, you have hydrogen as well. So remember that when you have those elements as elements on their own, not in a compound like in water, but as an element on their own, they're found in pairs. Similar to diatomics or polyatomics, and I'm not going to ask you to memorize a whole set of these, but they're a small class of compounds that when they're found in nature as elements, they're not bonded in pairs, but they're bonded in groups of more than one. So poly as a word means, or as a root, means many. So there's many atoms in the group. Ozone, O3 represents one, white phosphorus is P4, and S8 is sulfur. Now the last huge group of molecules is compounds, and that's when there's 2 or more different kinds of atoms chemically bonded together in a simple whole number ratio. You can't have half of an atom, you can't have 3/4 of an atom, you have 1s and 2s and 5s. So examples of these are water, sodium chloride, glucose, which is C6H12O6. And this is where we bring up our second law of the year, and that's the law of definite composition. And that law states that molecules of the same compound are always found in exactly the same number and type of atom bonded in exactly the same way. When we look at some carbon compounds, it's possible to have the same number of carbons and hydrogens in them. That's what we call an isomer, but they have different structural arrangements. They bond in different ways. And because of that, it's very important that it has to be the same number and type of atoms, but they also have to be bonded together in exactly the same manner so that every molecule in the compound is exactly the same. So when we look at compounds, this is a review of Science 10, we know that there are ionic compounds and covalent compounds. And we're going to start with a look at ionic. We'll focus on covalent next day. But ionic compounds are really easy to remember because they're made of, not surprisingly, ions. And we talked about last class the fact that ions are atoms that have gained or lost electrons in order to have a positive or negative charge. So remember that when we look at metal ions, they are positive. We call them cations. They will join with negative non-metal ions. We call those anions because we know from, I don't even know what science that is, Science 8 in electrostatics that opposite charges attract. If you have an ion that's floating around all on its own, that has to be aqueous. They're never found in the air or on the tabletop as a solid in an ion form on its own. They can, though, also be formed at high temperatures in the gaseous state, but this really isn't common or something you have to worry about. So when we form ionic compounds, just like atoms, contain charged particles but are neutral overall. So ionic compounds are neutral. They have no overall charge, so that means the sum of their positive charges must equal the sum of their negative charges. Remember that metals are electron donors, so their ions are positive. Non-metals are electron acceptors, so their ions are negative. So let's just look at a couple examples of ionic compounds being formed. If a sodium ion reacts with a chloride ion, they react in a 1-to-1 ratio. Sodium has a charge of +1, chloride has a charge of -1. So you need one of each in order for their charges to balance out and have a neutral compound overall. Magnesium ions, in contrast, when they pair up with another halide, bromide ions, react in a 2-to-1 ratio because magnesium has a 2+ charge, bromide has a 1 negative charge, so that means you need to have 2 of the bromides to neutralize or to balance out the 2 positive charges. So looking at magnesium phosphide being formed, magnesium as an ion has a 2+ charge, phosphide, phosphorus as an ion, has a 3- charge. So the lowest common multiple, the lowest number that those two charges can be multiplied and produce, is 6. In order to get 6 from 2, we have to multiply it by 3, so that means we need 3 of the magnesium ions. In order to get 6 of the 3- charges, we need to have 2 of them, so that means we need 2 of the phosphide ions. So overall, we produce a compound that's Mg3P2. The subscript immediately behind the ion identifies how many of that ion are there. Now looking at it in a picture form, this looks like this. So we look at the magnesiums and there's 2+ plus 2+ plus 2+ is 6 positives, 3- plus 3- for the phosphides is 6-. Notice that overall those charges balance out. And just as a quick little trick, and I know that some of you will have seen this in probably Science 9 before, you can see that when you look at the charge on the magnesium, where is it in the formula? It's directly behind the phosphorus. And when you look at the charge on the phosphorus, where do you notice it in the formula? It's directly behind the magnesium. So ionic equations actually look at how ions, which are aqueous, bond together to form ionic compounds. It shows the ions in their ionic compound being formed in their smallest whole number ratio. And that's actually where we're going to leave it for this video. We're going to work extensively on these skills in class next day, so be prepared for a bit of practice.